Hi guys, it's Sarah. I'm going to be covering the neurobiology of bipolar disorder. So, for a review of bipolar disorder, traditionally when people think of bipolar disorder, they think of mood swings, but we know there's more distinguishing factors. It was formerly called manic depressive disorder. Bipolar disorder is characterized by mood shifts from extreme highs or mania to extreme lows or depression. It can be categorized into bipolar 1 or bipolar 2. It may occur with additional symptoms called specifiers, such as bipolar 1 with psychotic features. So, bipolar 1, the DSM 5 criteria includes the presence of a distinct period of abnormal mood consisting of mania or major depressive symptoms, and it must last 1 week. And to be considered bipolar 1, it must include the manic episode. The mood disturbances cause a marked impairment in social or occupational functioning. So, likely disrupt their work or interpersonal relationships. And the manic episodes involve an inflated mood. Symptoms include inflated self-esteem, decreased need for sleep, talkative, pressured speech, or engaging in risky behaviors. Major depressive symptoms include depressed mood for most of the day, nearly every day, diminished interest in hobbies, significant weight loss or weight gain, fatigue, loss of energy, feelings of worthlessness or hopelessness. So, bipolar 2 also includes alterations in mood, but involve alterations between hypomania and depressive symptoms, and the episodes last at least 4 days. Hypomania symptoms are similar to mania symptoms, but they're decreased in severity, frequency, and duration. And then the symptoms of hypomania are usually not severe enough to cause marked impairment in social or occupational functioning. So, for neurobiology, mood disorders are linked to alterations in monoamine levels, receptor function, and related brain circuits. Some of the main monoamine systems implicated in bipolar are the noradrenergic and serotonergic systems. We know norepinephrine is involved in stress response and arousal, and we know serotonin is involved in regulation of anxiety and depression. So, alterations in these symptoms would lead to alterations in mood. Some noradrenergic alterations, studies have linked decreased norepinephrine levels to depression symptoms and higher norepinephrine levels to mania symptoms. Alterations in serotonergic neurotransmissions are associated with depressive symptoms. Studies have linked 5-HT1A receptor binding potential, or they showed that the receptor binding potential was decreased in the raphe, hippocampus, and amygdala in depressed patients. There's other serotonin receptor alterations, but this is just one example. So, other neurotransmitter systems implicated. Dopamine, it was reduced in depression and increased in mania. Studies show higher endogenous acetylcholine during depression and a decreased cholinergic tone during mania. GABA is an inhibitory neurotransmitter, and we know it has inhibitory effects on the ascending monoamine pathways, particularly the mesocortical and mesolimbic pathways. And we know these pathways are implicated in mood regulation. Reduction of GABA, or that lack of inhibition, has been found in depressed patients. And then glutamate is a major excitatory neurotransmitter. We know it binds to NMDA receptors. And then we also know that excess glutamate is associated with neurotoxic effects. There are high concentrations of NMDA receptors in the hippocampus. And so the hippocampus is particularly vulnerable to the neurotoxic effects of excess glutamate, and it leads to atrophy in the hippocampus. reviewing the hippocampus, we know it's part of the limbic system and is associated with social, cognitive, and emotional processing. So atrophy of this area could lead to alterations in mood. So hormonal and endocrine alterations. Studies have shown that severe and early stress or trauma and chronic stress have caused structural changes in the cerebral cortex and increased HPA, hypopituitary axis activity. Both of these are associated with the neuropathology of mood disorders. Some structural changes that have been linked to mood disorders involve decreased activity of brain-derived neurotropic growth factor, or BDNF. Chronic stress reduces BDNF, and BDNF usually plays a role in neurogenesis, so decreased activity results in altered neurogenesis and altered neuron function, leading to atrophy and decreased volume in the cortex. As far as the APA hyperactivity, it's also linked with chronic stress. Talked about hippocampal neurons, but they're highly neuroplastic and vulnerable to damage in different ways, and the HPA hyperactivity is another mechanism indicated in hippocampal damage. HPA hyperactivity causes hypercortisolemia. Persistent exposure to high cortisol levels ends up resulting in hippocampal atrophy. Studies found that hippocampal atrophy has been found in depressed patients, as well as increased HPA activity has been associated with mixed manic states. So Stahl had an illustration that was helpful for me, kind of relating the specific monoamine alterations to the different brain areas, and then the specific symptoms caused by each area. So here's that. And this one is related to depressive episodes. And then the same illustration, or type of illustration, but related to manic episodes. And these are both from Stahl. So genetic components. Results in family studies showed that if one parent has a mood disorder, that a child had a 25% chance of inheritance, and that chance doubled if both parents were affected. Also, studies have shown that if more family members are affected by a mood disorder, the child has a greater risk for inheritance. As far as specific genes, no single gene can be linked to depression or mania, but it's thought to be caused by many different vulnerability genes. People carrying the vulnerability genes are more likely to experience alteration in brain circuits and altered monoamine functions that we just discussed when exposed to epigenetic or environmental factors. Specific gene markers have been found, and two of them are alterations in chromosome 18q and 22q. So, immunological alterations, depressive disorders are associated with immunological, hard time saying that word, abnormalities, including decreased lymphocyte proliferation. Lymphocytes usually produce neuromodulators such as corticotropin releasing factor, cytokines, and interleukins. Alterations in these immunological mechanisms are associated with altered gene activity and immune dysfunction. Okay, I hope that made sense. Thank you.